Sharon, welcome to the MAP podcast. You are the co-founder and CEO of Lamini.ai, the leading enterprise LLM platform for fine-tuning. And we are going to talk about what that means. So welcome, excited to have you. Been looking forward to the conversation. As tends to be the case with those things, and you and I were just chatting a second ago before starting to record. I'd love to start with your story, including your very impressive educational background. Among other things, I read that at Harvard, you were the first person to do a joint degree in classics and computer science. So how does something like this happen?
Yes. Well, thank you so much for having me. Very excited to be here. Yeah, I can give a little bit of history. I mean, actually most recently I was computer science faculty at Stanford, leading a research group in generative AI, generative models, also teaching there. I teach actually about 250,000 students and professionals online on Coursera in generative AI. The most recent course being fine-tuning LLMs using Lamini. I did my PhD at Stanford in generative models, generative AI. I've been doing this for almost a decade. But before my PhD, I was actually a product manager at Google, so machine learning product manager on Google Cloud. And I was enamored with product and user experience. And how I become like that classics and computer science person actually comes from a very different background than most people, which is I started off in literature and loving languages, loving, Latin, ancient Greek, French, as we talked about previously. And I'm a people person. I love people. I never thought I'd fall in love with a thing, which is a generative model, for example. So I moved into computer science and found it by way of user experience. I actually felt very intimidated working with technology when I grew up. So user experience was like this holy grail of, oh, we can actually design systems to make them not intimidating for other people to use. I want to do that. I want to make it so much easier for people to use these systems. So that's part of why I'm in technology at all. And of course, I fell in love with generative models completely on a whim. I had the joke is I was trying to drop out of the Stanford PhD to start a company like Larry and Sergey. And I failed to drop out because I just fell in love with generative models because they were so magical. And that is a joke, but it is genuinely, like, I told my PhD advisor, Andrew Ng, that day one that my plan was to drop out. So it was genuinely my true path. So yeah, like bringing together user experience, accessibility, making technology easier to use and access, plus my love of generative models is kind of how this company was born. Lamini was born, where I think like the future is where everyone should be able to own their own LLMs, and the path to getting there is democratizing access to actually being able to build it, make it possible for people, for enterprises to be able to build it. And this is especially true in this age where LLMs are, I believe, the new IP. So,
Okay.
yeah.
All right. Fascinating. Thanks for sharing. Since Lamini is an enterprise platform for fine-tuning LLMs, maybe a great place to start would be with a little bit of definitions and sort of if you could help us contrast training and pre-training with prompt engineering and then fine-tuning, and sort of explain what for a broad audience of people looking to learn about the space, what those things mean and how different they are.
Right, of course. So fine-tuning is the technology that got from a research project in 2020 called GPT-3 and turned that into ChatGPT, a billion-dollar app, right? So that was the technology that made that happen. And what it's doing is it's modifying the large language model to take in data, learn new knowledge from that data, be able to have certain guardrails, like you've probably seen as an AI large language model. I can't answer that question, or I'm a little bit uncertain about that question, and be able to give more consistent outputs. And so that's the technology behind it. Of course, there are different challenges. Happy to chat through what makes it hard. It's very hard. And that's in contrast to prompt engineering, which people have been hearing about. Prompt engineering is actually something that everyone has been doing for a long time, before even, I think a decade almost, before even large language models came about. I think Google is essentially prompt engineering. When you edit your query to get the results that you want, that's prompt engineering. And so prompt engineering is great when you, let's say you don't have a lot of data, and all you want to do is just ask the language model something and be able to actually interact with the language model. So prompt engineering is just a way to interact with a system, whether that be a language model or even a search engine, to be able to get different outputs from the system that you would want. And it's very, very good when you don't have a lot of data. Of course, you just don't have examples to necessarily steer it in a certain direction. And it's very, very easy to get started. And that's in contrast to fine tuning, where fine tuning is not as easy to get started. You do need, some technical lift, especially on the data side these days. But it does work really well when you have a lot of data. And of course, these are not mutually exclusive techniques. You, of course, can do prompt engineering on top of a fine-tuned model. ChatGPT, you're obviously doing prompt engineering on ChatGPT, which is a fine-tuned model. And so, yeah, that's how I would think about it from those terms. Is that helpful?
Okay, great. Yeah, that's very helpful. And just drive it home completely, training is what you do even like before that. So that's the possibly $1 billion effort of building the model, and before you do the fine tuning.
Yes. Oh yeah, maybe the stages of what the large language model goes through. So initially it knows absolutely nothing. It actually can't even produce an English sentence or English words. And what you do is, the pre-training phase, what it's known as, is just putting in a ton of data from the internet that's been cleaned, scraped, etc., and having it learn from that so that it gets a basic understanding of English knowledge and certain skills. And I would say like language skills, perhaps, maybe not English necessarily. It could be a different language or a different domain. And so that's kind of what the pre-training phase is known as. And that is really expensive, costs billions of dollars to develop, especially different iterations of it. And that's kind of what's known as those different base models, like GPT-3 initially, Llama 2, some of those that have come out. And then fine-tuning makes the model actually be able to interact with different interfaces, essentially. So be able to actually have a chat discussion much more consistently.
Okay, great. All right. So thank you very much for that. So definitions aside, just to take on your offer to explain why fine tuning is difficult. Like, I'd love to overview of the challenges.
Yes, of course. So to get fine tuning right, it's difficult, and maybe even on like the team side, you can tell that it's a big team of top AI engineers at OpenAI, for example, being able to make that actually work effectively for them. And I would kind of break it down into two different categories. One is convergence. So like getting the model to do something called be able to converge is something that's not very easy and automatic right now. And it requires machine learning expertise to make it happen. And that's where you tune these things called hyperparameters to make the model nudge towards a place where it actually improves, as opposed to go off the rails completely. And by off the rails, I mean like completely off the rails. It forgets English, etc. So that's one path. I think another thing that's very difficult is we're working with probabilistic systems. So what that means is that you might need to do many different iterations. You won't get it on your first shot necessarily, and you might need to train the model several times to be able to get the results that you expect and that you would want. And so as a result, efficiency is extremely important. So to be able to do this process very efficiently could actually speed it up significantly. And so, to address both of these things at Lamini, we basically offer, different autoconvergence algorithms for specific different use cases that have been tuned for those use cases. And then for efficiency, we have built in parameter efficient fine tuning with different techniques to train slices of the model to very efficiently be able to adapt it to different use cases. And by efficiency, I mean, it's instead of something that might take weeks or even months. That's bringing it down to even like the millisecond level.
Okay, great. All right, so that's a great segue into the company itself and then the platform, and let us go into all the things. So when did you start the company?
Oh, we started the company last year before ChatGPT came out.
Very, very young company, and but it seems that you've achieved a lot, and we'll talk about some of this in a minute. So it's an enterprise platform for LLM fine tuning. So you mentioned a couple of things, but maybe give us like an overall product tour. Where does it start? Where does it end? What do you currently have? What are you building? Yeah, a little bit of a tour would be great.
Yeah, okay, a little tour. So, okay, so for the product, exactly what's going, what goes into it. So, developers use our products, so software engineers at different enterprises today, and they're ingesting data. Maybe that's with some of our partners like Snowflake, Databricks, and Nutanix. And they bring some of their, either their own models or models on Hugging Face, like any model from Hugging Face, essentially. The most popular one being Llama 2. That series, and they put it into Lamini. And the way they put into Lamini is through different SDKs that we have to easily, be able to ingest that data in different formats, whether that be raw docs data, just documents, raw text data, or if that is something where they want an agent flow, different operators being able to use different tools or be able to route a request from a user to a human or an LLM. And inside of the Lamini product, I would kind of break it down in a couple components. So one component is definitely the fine tuning piece, where we have this auto convergence piece, this parameter efficient fine tuning efficiency piece. We have retrieval augmented fine tuning, which is like merging a bit of the retrieval work out there with fine tuning. And we have RLHF, so reinforcement learning with human feedback. And then on the inference side of things, we have, and what inference is after you fine tune the model, or even before you fine tune the model, you want to be able to run the model efficiently. You want it to maybe give out structured output. So we provide interfaces to do that. And then finally, I would say like all of this whole system could only run efficiently on compute. So we are, compute agnostic. So we actually can run on both. We can run on different VPCs, on NVIDIA chips. And actually, one special thing is we are the only folks who can actually run your language models on top of AMD GPUs. So that unlocks, what that means is that unlocks about 20,000 GPUs readily available today for enterprises to be able to use. And to get a sense of what that means you can train GPT-4.
Okay, super great. So to unpack some of this, so you mentioned retrieval augmented fine tuning. Is that the same thing, or is that different from retrieval augmented generation? Is that
yes,
in terms or different?
Great question. They are two different things. So we have simple SDKs on top of our system for RAG, retrieval augmented generation, which is very common these days. Retrieval augmented fine tuning is taking that and to the next level and to incorporate that into the training process. So retrieval augmented generation, RAG, which is very commonly used today, is a way to actually get information in at inference time during prompt engineering, essentially. But for the model to learn new knowledge, retrieval augmented fine tuning is actually incorporating that retrieval technology into the fine tuning process. And something that I'm very, very excited about is these two very big communities kind of being moved together. So one community is, the AI large language model community, and the other community has, decades of research on information retrieval. And I'm very excited to, see these two communities really converge to make these models more powerful.
Yeah, and just to play it back in layman's term.
Yeah. Oh yeah, sorry.
No, this is great. RAG is just basically checking the information, whereas retrieval augmented fine tuning would be knowing the information. Is that one way?
Yes.
Okay. Mm-hmm. Okay, so that's one, but then you can do both. So you can do the
Yes,
fine tuning, which is the more advanced one, but you can also do RAG. So you integrate with vector databases and that part of the world.
Yep. And
Great.
you absolutely should do both to get the most powerful model. Yeah.
Okay. So that was one thing that caught my attention, what you said. Another thing is RLHF. So do you want to talk about what that means, both in general, but also in the context of the enterprise on a sort of private basis?
Yes. So RLHF stands for Reinforcement Learning with Human Feedback. And that's one of the techniques that was used by OpenAI, and of course now a few different folks to build ChatGPT and several different models. And what it is at a conceptual level is being able to incorporate human feedback back into the model. Basically, you can think of it as thumbs up, thumbs down, but it really is like a ranking of, hey, the model said these 5 things, which one was the best, which one was the least, which one was the worst, excuse me, and how do we actually take in that feedback back into the model as another kind of rich data set so the model knows how it should be actually behaving. And so this is a great way to actually incorporate what I view as one, usage data. So being able to, as your users use your product, being able to incorporate that back into the model very easily. And then I also take actually quite an opinionated approach to this, which is not necessarily, I question the H in RLHF. I don't think it necessarily has to be a human. And I know Anthropic has touched on this a little bit in some of their recent papers over the past year, which is that why can't it be another LLM or a pipeline of LLMs that can help with that feedback? I think manual labeling is very tedious, especially for our target user, which is a software engineer. And I don't think people should necessarily have to do all that if zero-shot large language models are actually doing quite well. So using a large language model prompt engineering is actually doing quite well enough to be able to actually transform data.
Yeah, that's really interesting. You anticipated my next question, which is that what I know, and I'm maybe wrong, but about RLHF in the context of OpenAI or others providers is largely it's an outsourced operation in like some kind of overseas like places where people will spend hours and hours just back to the model. So I was wondering what that meant in the context of an enterprise, and because it almost feels like so there's a human aspect, but there's like kind of like the UI UX aspect of this. Like, are we all expected as enterprise users or business users to be like sitting down in front of the model and keep giving it thumbs up or thumbs down? But it sounds like that could be the case, but like most importantly, just to play it back, the future is actual models doing this for on replacing humans for this.
Yes, it is actually, I think there are models, but then where humans come in isn't this weird outsourced task force in the Philippines doing labeling. It's actually just your users using your product. And so there's ways to bake this into a product, a user experience that I think it's actually quite standard. When I think of a product like Amplitude, for example, it's able to look at, again, very just standard software engineering, standard products, be able to see how users are engaging with a product and be able to segment those users and also understand like all the clicks that are going into what a user is doing. And then you're able to do analysis on, hey, these are users that successfully went down this funnel, et cetera. And I think the same thing can apply here. The absolute same thing can apply here. Of course, I think people are a little bit, worried with language models. They don't even grasp it, but I think that's the future. The future is analyzing, hey, based on, in the same vein, based on how users are interacting with this product. Maybe it's, editing something it generated. Maybe it's, replacing it. Maybe it's accepting it and like sending that email, for example, if it generated an email. Those are all user engagements that can then be fed in via RLHF, right? So that's my view of it. It's not going to be this, I hope not, at least sombering view of outsourced labor for this, which based on my experience for, generic tasks, that's actually doable. But for very expert tasks, that's actually very, very difficult. And maybe just to give an anecdote, during my PhD at Stanford, when I was working on various different AI models, I worked on a AI pathology project where we had to detect basically a bacteria that indicated stomach cancer inside of different, pathology slides, biopsies. And we couldn't get labels from our board certified pathologists at Stanford because their time is very valuable. They were very generous with their time, but I was like, maybe you should go save some people. And I will learn. I did actually. I spent all my time learning and doing flashcards with Anki flashcards and learning what H. pylori looked like, this bacteria looked like, and segmenting it on slides and iterating over and over and over again. And that was both valuable, not just because, PhD students' time is essentially an indentured servitude time. No, I'm kidding. But essentially, but essentially also because I was training the AI system. I was training the models. So I actually understood how to iterate on what data labeling looked like that dramatically influenced how the model would behave. And when we got the board certified pathologist to do it, it turned into a model that was actually overconfident because they weren't sure, like, oh, was I supposed to write uncertain over here? Or I just marked everything, So it actually helped that I knew. And by the end of it, according to them, I was actually better than their residents, the pathology residents, and I got the same agreement rate as 2 board certified pathologists. So like it got to that level, but that is not something we tried outsourcing actually to like scale AI, et cetera. None of that worked. It had to basically be me. So my belief is that the people building and the people understanding the products will be able to, either through a product kind of like Amplitude, but for large language models or something like that, will be able to extract those insights and be able to bake them in and further improve the models.
Mm-hmm. Amazing. And do you think there is a like a clear path to basically solving the hallucination problem that like everybody is thinking about? Like, so between RAG and retrieval augmented, fine tuning, and then what should we call it, model assisted RLHF. Do you think that you go like into the 99% correct kind of model performance, or where do you think this is going?
I think we can get to that performance today, but it's based on how you scope out the problem. So if it's a very narrow scope, of course you can get that. Now, the more and more you broaden the scope, the reason why ChatGPT is hard to put guardrails on is because they're trying to go after every possible use case, right? So that's actually quite difficult. That's very general and it's hard to predict. So as a result, it's really hard to put together an evaluation set before you see what users actually use it for creative tasks. And I actually think it's a great thing almost that we don't even know what people use it for. I think for a more scoped project that we're seeing with our customers and enterprises is, when it's domain specific, experts do actually understand some of the parameters around it. So I think some of the things to reduce hallucination with fine tuning is actually drawing these boundaries for the model, these guardrails essentially for when it should talk about a topic and not talk about a topic. For example, we have demos out there that show a fine-tuned model that has these boundaries on it, and it only talks about Lamini. Like it won't talk about any other topic. It's the same thing that makes these models say, as a large language model, I can't blah blah blah. But it's because we can scope it out just to Lamini, and so that makes it actually quite easy to draw those boundaries versus everything, if that makes sense.
Mm-hmm. Very interesting. So you mentioned as well, as we were describing the product, grabbing models of Hugging Face and Llama 2 as an example. So this, a discussion around smaller models and open source models versus commercial, like the very large models. I mean, it sounds without. My words, not yours, but that you're very much in the camp of like smaller models and open source for discrete use cases. Is that fair?
I think it depends on how you define small. So we can train up to 100 billion parameters.
Okay.
So that's, I think, sometimes in the large range now. And what we encourage is actually starting with some of the larger models that are just start at a better checkpoint and then moving smaller to optimize for efficiency. And so what that usually means, a common path is not like your own custom 100 billion parameter model, which of course, happy to take that in, is starting off with Llama 270 billion and starting from there. And of course, our customers are, playing with all the different Llama series. And I think to determine also other constraints are around compute. So how much you want to be spending on compute also matters. And then how much data you have. So the amount of data that you have significantly influences which model you should choose. Because if you don't have a lot of data, sometimes that might mean, a smaller model can be better to like fully utilize all of that if you're doing pretty heavy training on it. And I would call that like the domain adaptation training, like the very heavy training on it. But if you're doing something very lightweight on top of something, then actually starting with a bigger model where you want it to have some of those generic use cases is better. So it really depends on what data you have and what use case you have. And I think the industry is starting to learn what that is my sense.
As I was prepping for this, I also read about your PEFT framework. I don't know if that's the right term, framework, but PEFT, which stands for parameter efficient fine tuning, and then with the concept of model switching. So what does that mean?
Yes, what does model switching mean? So let's say you have a single server, like a single node with 8 GPUs or something like that, or you just have, let's say, a single GPU. Let's make this super easy. And you have a model that can run on that server, all right, on that GPU. Great. What if you have, let's say you have 1,000 different customers and you fine-tuned a model for every single one of those customers, okay? You would need 1,000 GPUs to serve each of them and that's like doing it the normal way. You would need 1,000 GPUs. That is really expensive. And also they're not super available right now, unless you want to go the AMD route with us. So that is not something we recommend necessarily to scale it out to 1,000 GPUs per customer. So what can you do? What does model switching mean? If you wanted to just use one GPU and switch across those 1,000 customers, so let's say 1,000 customers are hitting their models and you're just switching it on the GPUs, you're changing which models loaded up on the GPU. The estimate is about 3 months of switching time, just pure sheer switching time. It would take 3 months to serve all 1,000 customers, and I don't think that's quite real time inference from my vantage point. You ask a model something, 3 months later it comes back. It better be right, by the way. So that's what that is. And then so with the technology that we've used with parameter efficient fine tuning and just like different efficiency methods, that time to switch across 1,000 models is 3 milliseconds. So like a very, very big difference. That's a drastic difference, which it suddenly means you don't need those 1,000 GPUs. You just need that one, right? And that becomes a dramatic shift in how you even think about your product or how you even scale out compute. Like when we talk to customers, this completely changes how they even think about fine tuning and how adapting models to every single one of their users, whether that be 1,000 that we just talked about, 10,000, 1,000,000, 10 million, and it just becomes a very different type of thinking, essentially.
Okay, fascinating. And you mentioned agents as well. So first of all, maybe let's start with the definition, and then what is a reality in the enterprise of agents and chains? And obviously it's a topic that a lot of people have been excited about, but I'm wondering what's how that manifests in reality so far.
Yeah, so that is one of our common use cases. So what customers will do is build out essentially these agents, which call out either different language models or the same model, also call out different tools and APIs that they might have internally. And one of those tools could be go call a person for at the end of the usual customer service route. So these agents are essentially, I would say there are a couple different components. One is kind of a routing ability, so being able to route to those different APIs, and that's the language model's ability to be able to plan and execute a task. So planning is actually something that is in the wheelhouse of large language models. This is an ability that has emerged from these large language models that have been not as great before, I would say. So this has influenced not just these agents, but also things like robotics today. And it's very exciting that they can plan. So like planning like a 5-step process, for example, to be able to hit, API 1, API 2. If, all that fails at the 3rd step, call a human, that's like the planning stage. So it's able to then hit those APIs, and some of those APIs might be itself to ask a question, return some kind of value, and be able to then go on to the next step. So I think that's a very general framework that people are using today, and being able to build out to many different use cases. I think some of the common ones are the user onboarding, or reminders, customer service, of course. But as you can imagine, these can get pretty specific to certain domains. And for those domains, customers are collecting a lot of data from them as they deploy these models and collect, or already have data. And then that is used to then train the model to be more consistent, to be better at planning for their specific use case, to hit like the targets that they want it to hit, and to be able to basically return a better result and continually improve it over time.
Mm-hmm. The model to kind of API sort of action seems reasonably straightforward. Is there a difference when you do like model to model to model kind of chains? Is there like are there like different levels of complexity?
I would say that every model call in a chain results in, because these models are not 100%, does result in some form of error. So error does compound. It also results in latency for every model call. So I would say that those are considerations to take in when doing a massive chain of large language models. And the ways to reduce it are you take the input of the first thing into the chain, you take the output of the last thing, and you fine tune only one model to do the whole thing, for example. And so that's a common kind of path as well. Yeah, so that's kind of how I would approach that. But first I would prototype it, and it's okay. It's multiple chains long, totally okay. You're getting the prototype up, you want a general sense of what's going on, and then you're like, okay, now we're ready for production. We want to optimize this. We want this to improve over time. Let's go down that route.
Mm-hmm. Maybe a quick word on that exciting partnership with AMD. You alluded to it up front, but that's actually a product, or like a package. I think you call it the Super-station. Is that correct?
Yes, our LLM Super-station with AMD. So yes, our secret's out. We've actually, in terms of our hosted service, the Lamini hosted service over the past year has been running on AMD GPUs only. We haven't been running on NVIDIA chips. Of course, for our customers, we have, our customers, when they're in their VPCs, we run the Lamini software package on top of their NVIDIA GPUs, almost exclusively for that. And some of our customers now have both, because they have now purchased essentially this these LLM Super-stations that include, Lamini pre-installed on them with AMD compute. And the reason for this is because of the compute shortage. I think without the compute shortage, it would not be exactly a thing we necessarily be doing very explicitly. But with a compute shortage, needing GPUs that are powerful enough to be able to run some of these models, Llama 70 billion, but even Llama 13 billion, and be able to fine tune it, it's compute intensive. So you need that compute. And as a result, to unblock a lot of our customers who can't get them on a tier 1 cloud, and by the way, that includes Fortune 500 and very large enterprises who can't do that. So we've offered this as one solution to doing that. And we offer it in 2 ways. Of course, we recommend our hosted solution all the time, which is running it and hosted in our data center. But we also have, an on-premise solution. Essentially, we would ship the box to you, and your DevOps team could handle it. And we do have customers doing that as well.
Great. And part of the realization was that AMD Instinct accelerators are as powerful as NVIDIA Cuda. Is that was that the analysis?
Yes. So maybe a bit of background on that. It does extend a bit beyond a simple realization. It's been in the works for multiple years before the company even started. So my co-founder, Greg Diamos, was one of the original CUDA architects at NVIDIA in 2008, and has built out and shipped very large language models in production to over 1 billion users, for example, in the Baidu search engine. One of the earliest examples of that. His team has now built out all the major foundation models, including GPT-3, 4, Claude, Llama, Llama 2, et cetera. So like very big team there. He founded ML ML Commons, basically the standard for machine learning performance in the industry, to make these models very efficient, both for training and inference. So with that expertise for many years and with the relationships, deep relationships with AMD, we were able to actually get this working. And this is with the foresight of something called scaling laws that Greg co-invented several years ago, about a decade ago.
Yeah, what is that? I read about this a little bit. Oh, I saw it come up as I was reading. What are the LLM scaling laws? What does it mean?
It's a crazy thing. It's actually a simple formula essentially for intelligence. So what it's saying is that with more compute and data, linearly, the model will improve. And that's almost a very crazy thing to realize and to see in these models. So that's what it's saying. So he knew from the onset, from that moment, and everyone on that team clearly knew, because they built out now the big foundation models, is compute matters a lot and data matters a lot, right? So public data has gotten us very far with all these great models today. They're amazing. I believe that the next frontier is enterprise data. And so that's why we're building this company as well. And compute matters a ton, and that's why we engaged with AMD before even ChatGPT came out, because it's like a very long process of working together and getting this to work. But it's been very fruitful, and I'm very, very excited because we have reached software parity with essentially Cuda. And so what that means is a huge amount of AMD GPUs are now available for use by our customers. And what that means for them is large language models are unlocked for them.
Amazing. Okay. Speaking of customers, and switching maybe like away from the product into the sort of the go-to-market, what are you seeing and learning? I was thinking through this conversation, I mean, like obviously you're just at the very edge of like this world and just building some amazing stuff. I just put myself in the shoes of a customer in just like the level of precision and sophistication and all the things. Obviously it's exciting, but maybe daunting. Like, do you find yourself sort of doing a lot of hand holding? Like how does that I guess what is your experience to date in interacting with customers in the real world?
Yeah, I would say I'm actually impressed with the rate of learning that customers have had over the past year. We started before ChatGPT, and it was very preliminary. Like customers didn't even know the word. Obviously, generative AI was not a thing. Large language models wasn't even a thing. So just a very different ecosystem. That was obviously a huge amount of knowledge transfer that we would have to do for a customer. And it also narrowed who our initial customers could be. Today, customers are learning very fast. And we see customers at varying levels of the maturity curve, but they are learning very fast. So they'll come back to us after a month or something and be like, we're ready. So I'm seeing that as really fast. And of course, I've been trying to contribute to that as well through the courses like fine-tuning LLMs, which now has reached many customers who have now tried all those techniques and best practices. And I'm really happy about that. It's a scalable way of doing it. But of course, we do have change management as a thing. It is still realistically a thing at different levels of a company. And realistically having, experience and also been around, our team has been around a lot of these deployments in the past. It's that it isn't easy. There's buy-in that needs to happen at every level. And so I think that's a piece of it. But of course, that's almost a piece of every enterprise sale.
Yeah. Any emerging use case or use cases that seem to be popular or things that are turning out to be much harder than expected? Any learnings around use cases?
Yeah, so in terms of use cases, I think they're actually very obvious ones, and they should be very obvious. It's essentially, I want ChatGPT on my data, so chatting over some kind of document. So that's very, very common. Again, the agent one, operator one is very, very common as well. What's not working is getting, compute to scale out. Of course, we're unblocking that, and also encouraging customers to deploy much faster. So I think something that, it's a very hard thing to be able to deploy these models quickly because it's a new piece of technology. But I will say all of the customers who do deploy fast essentially will reap the benefits of it, because even if you launch something that's embarrassing at first, like GitHub Copilot was kind of embarrassing at first. I think there was a lot of, and people didn't say necessarily positive things, but it improves over time. That's the whole point of it. It improves your usage, improves your data. And so that's what deploying faster means. And I know it can be very challenging for folks to deploy something that feels like it's a probabilistic system when they're used to deploying deterministic systems.
Cool, awesome. Well, that feels like a wonderful place to leave it. Thank you so much. I really enjoyed this conversation, and let's do this again. All right. Well, that feels like a wonderful place to leave it. Thank you so much. Really enjoyed this conversation. Where can people find you online and the courses that you mentioned, and how do they learn more about you and the company?
Oh, of course. So you can find me on a few different platforms. Twitter, LinkedIn are my most common ones. You can also reach out to me over email, sharon@lamini.ai. In terms of the company, it's lamini.ai. Lamini.com will also reroute you there. And in terms of the courses, they're on Coursera, so they're free, or should be free, I hope. And they're free to anyone who wants to just learn about them and play with the technology. It's Lamini open core there, so you can actually hit our servers, hit AMD servers essentially as you run through it.
All right, terrific. Thank you so much, Sharon.
Thank you so much, Matt. Really appreciate it.